welcome back. Today I'm going to be talking about enzymes. All right, we're going to be talking about enzymes. So what are enzymes? So first of all, enzymes are proteins. They're a type of protein. I mentioned them when I did the video about the macromolecules protein, and they are also catalysts. So catalysts are needed in chemical reactions and metabolic reactions, and what they basically do is they help to speed up the reaction. So without enzymes, can the reaction get to the product level? Yes, but it really helps to have enzymes. So that's really what enzymes do, helping to speed up metabolic reaction. And the term catalysts are not just limited to enzymes. So heat could be a catalyst. So let's say you have a tea and you're trying to drink your tea and you have your water. Hot water is going to be a lot faster if you want to brew your tea than if you just leave your tea bag in there. By the end of the day, a couple of hours, your tea, you're going to have your tea, but you could just have it with hot water. So that's going to be an example of a catalyst. So I just wanted to mention that so that you get the point. And the way they do this is by lowering the activation energy of a chemical reaction. In the next slide, I'm going to talk about how they do that. So as a result of this, because of these enzymes, our bodies are able to undergo many reactions in minutes. You have basically, factory workers, products being made in minutes. All right. So this also can lead to an increase in the speed of reaction. And one thing about enzymes is that they end in ASE. So that's going to be one clue. So if you see words like lactase, protease, amylase, all right, polymerase, RNA polymerase, ligase, those are going to be enzymes. And obviously, we use enzymes for digestion. And one of the things about enzymes in terms of digestion is they have to be at a certain temperature. In the human body, that's going to be at the normal room temperature. And the normal room temperature or the normal body temperature. If the body's too hot, it's too cold, that could definitely affect the job of enzymes. So, for example, we see that lipase digests lipids, lactase digests lactose, sucrase digests sucrose. So if you're looking at this, you're seeing a trend here, very specific. You cannot use lactase to digest lipids. You're not going to use lactase to digest starch, for example. So that's something about enzymes. They're very specific, like a lock and a key. Let's say you live in an apartment complex or you live on the street that all the houses look exactly the same. Your key necessarily will not open your neighbor's house, or your neighbor's key will not open yours, even though they look exactly the same. So why? Because of that specificity. So we're going to be talking about them in the next couple of slides. So this slide is I really want to talk about enzymes and activation energy. So one of the things you're going to first see here is that you have the reactants. I've talked about reactants. And in order for the reactants to become products, there's a type of energy needed, and we call this energy activation energy. So if you look at without an enzyme, it took a lot longer for the reactants to become products. But with enzymes, the time is not just cut in half, almost like a quarter of amount of time needed. So this is really how or why enzymes are needed. It doesn't necessarily mean that the reactants would never become a product. It would not get to the product level. It would just take a lot longer. So what we would say about enzymes is that they decrease the activation energy in order for a reactant to get to a product. So here we're seeing what's going on here. Again, looking at the specificity. This purple thing right here is going to be the enzyme, and then this yellow thing right here would be the substrate. The substrate as like the reactants. And one of the things you notice is as soon as the substrate binds to the enzyme changes shape. So I want you to take a look at that. The enzyme changes shape. The reactants, the substrate, changes shape as well, almost like a signal, because I always say this, our cells don't really talk, they don't have mouth, but they have to be able to communicate like, well, I'm busy, I'm doing something else right now. So by changing the shape, the other cells, the other substrates will know, oh, this enzyme is occupied right now. And during that time, a bond is going to be formed. A bond will be formed, and once that bond is formed, there's energy absorbed, water is going to be released. If you remember, going back to the macromolecules, if you have not seen those videos, please go back and watch them. And then once a bond is formed, which you have a product now, the substrate, or now the product, we now call it a new name, is released, and then the enzyme will assume its original shape and go back, and the whole process will start all over again. I remember I talked about reactants when I was talking about the chemical reactions, so be sure to check that video out as well. So sometimes students get confused about reactants and products. So I give the example, let's say you want to bake a cake, all right? You have your eggs, your flour, your milk, your sugar. Those are going to be your reactants. But by the time you're done baking the cake, if someone asks you, hey, what are you eating? You're not going to say, well, I'm eating some flour, some eggs, some milk. No, you're going to say, oh, I'm eating some, I'm having a slice of cake, all right? So that cake is the product. But does that mean that those reactants are still there? Yes, but we now call it looks different. We call it a different name. Talk about a clinical case, or how enzymes are important in the human body, and that's going to be lactose intolerance. So we have a number of people who are lactose intolerant, and what that basically means is that they're unable to digest or break down milk, or any milk products like cheese, like milkshake, for example, anything that basically has lactose. Lactose is a sugar found in milk. I mentioned it again when I was talking about the carbohydrates. So they are unable to break the milk product down because they lack an enzyme called lactase. So without lactase, the lactose builds up in their body, specifically in their intestines, and obviously this will cause symptoms such as bloating, diarrhea, nausea, gas, abdominal cramps, and pain. Very, very uncomfortable, and even nausea. All right, so does that mean that the lactose product will not be digested? It will, because remember, going back to our energy of activation, the reactants will eventually reach the product level. It's just taking a lot longer, and while it's taking a lot longer, it's causing all these symptoms. It's very important to note that lactose intolerant does not mean that this is a milk allergy. Milk allergy is totally different from being lactose intolerant. So what could be the cause of it? Most of the time it could be hereditary. It runs in the family. Sometimes it's sparked by an injury, an infection, or disease. Someone goes their entire life, they were drinking milk products, and all of a sudden, after an injury or infection or disease, they become lactose intolerant. Or it could be congenital, which is really rare. Studies have shown that some babies were born without producing lactase, but that's rare. And sometimes, some people, all their lives, childhood, they had milkshakes and they had milk products, and then they reach their 20s and then they discover like, oh, I can't have any milk products anymore. So sometimes it does manifest in late teens or early 20s. So what's the diagnosis? Lactose tolerance test is done. Hydrogen breath test could be done. Stool acidity test, which is more commonly used in infants and children. And in terms of treatment, allergens, allergists basically believe that, just introducing little amounts of lactose products into your diet, and or seeing which ones you can tolerate, or having lactase their enzyme tablets now, like meds that you can just put in your milk so that you can drink it, or you can have like almond milk or soy milk and so on. But studies also show that even when people are lactose intolerant, there's still some dairy products that they can tolerate. So maybe you can just stick to that. So that's the end of enzyme topic today. And thank you so much. Bye-bye.